All right, moving on to imaginary numbers. This is going to be different. Might be, and again, you may have been introduced to these in Algebra 1, or you may not have. So we'll just have to we'll go from there. It's really not that bad. But this is, you might be thinking imaginary. What does that even mean? Well, we're going to solve this quadratic equation right here to kind of figure out where they come from. Try to solve this quadratic equation, x squared plus 9 equals 0. So it's not factorable. Like a lot of students think, oh, it's x plus, don't write this down. They think it's like x plus 3, or I've heard x minus 3, but those don't work. X plus 3, x minus 3, that's x squared minus 9, right? So that doesn't work. This is x squared plus 6x plus 9. And then if you go minus, it's minus 6x plus 9. So nothing works for factoring. This cannot be factored. So the only other way to solve this equation would be to subtract 9 from both sides and get x squared minus 9, equals negative 9. X squared equals negative 9. And then take the square root. What that produces is the square root of negative 9. What's the square root of negative 9? Now, if we had an in-class discussion, I think I'd hear, you could think in your head what it is right now. Well, oh, it's 3, it's negative 3. These are the things I hear. It's 3, it's negative 3, it's 9, it's negative 9. I hear all these different answers, and the answer is no, none of those. The square root of negative 9 means I got to find a number, like the square root of 9, for example, is 3, right? Or negative 3, because 3 squared, 3 times 3 is 9, and negative 3 squared is 9. So the square root of 9 is 3 or negative 3. But square root of negative 9 means we got to find a number times itself that gives me negative 9. There's no such thing. You can't multiply a number times itself and get a negative number. You can't get any negative. Because when you square, you always get a positive. Because a positive times a positive is a positive. And a negative times a negative is also a positive number. So you can't possibly get a negative number. Therefore, you cannot take the square root of a negative number. You can't have a negative under the radical or in the radicand. So for these situations, we have what's called an imaginary number, an imaginary unit. Because the square root of negative 1 can be factored, like the square root of negative 9 can be written as the square root of 9 times the square root of negative 1. 9 times negative 1 is negative 9. The square root of 9 is 3. I can do that. But the square root of negative 1, that's really the problem. I can't take the square root of a negative. So instead of writing square root of negative 1, square root of negative 1, square root of negative 1 throughout all these situations, mathematician a long time ago came up with a letter, a variable. It's not a variable. It's actually a constant letter that represents, it's more like a symbol, that represents the square root of negative 1. The square root of negative 1 is going to be represented by the letter I, okay? It's not a variable. It's not like x. It's not like y. It's more like pi. Like pi is a number, 3.14, right? I is a number. It's the square root of negative 1. However, it's not a real number. It is not a real number because we just talked about you can't take the square root of a negative. So anyways, whenever you see square root of negative 1, the next step is going to be to put the I with it, to replace it with an I. All right? So from this definition here, we need to come up with what I squared would be, because in our problems that we're going to be doing, you'll see I squared comes up a lot. I comes up a lot, but so does I squared. I squared, if you think about it, would be the square root of negative 1 squared. And what happens, remember radical equations? Radical x minus 3 equals 4. What would you do? You would square both sides, and then you would say the square cancels the square root and you just get x minus 3. Remember doing that? Well, it's the same thing here. The square would cancel the square root and you're left with just negative 1. So what this means is the I squared, whenever you see I squared, it's simply negative 1. So, to recap, I is the square root of negative 1, but I squared, and when you get I squared in a problem, you're going to replace it with just plain old negative 1. So So here's a procedure for simplifying radicals with imaginary numbers. So we're going to be getting these square roots of negatives and simplifying them. The square root of negative 49, most basic example, okay? Square root of negative 49, we could simplify that by going radical 49 times radical negative 1. We're going to take out that negative 1. Now I can break down 49 just like we used to do radicals. 7 times 7, a pair of 7s, right? And that's it. That's it. So this is 7. That's a pair of 7s, gives us a 7. But then we have this leftover radical negative 1, but we just talked about the radical negative 1 that is equal to just I. So you're going to replace that radical negative 1 with an I. So therefore, the square root of negative 49 is 7I. Let's do the same thing here. And again, we're going to break this down, but we're going to first take out that negative 1. 75, negative 1. Now we'll break down our 75. 25 times 3, 5 times 5. Pair of 5s, 5 times the 3 that was already there. 15. This is I, and then radical 3. 15I radical 3. The I goes before the radical. All right, and then this one here, I have 108, so that's going to be radical 108, negative 1, and then the 108 is 54 times 2, and then 27 times 2, and then 9 times 3, and then 3 times 3. So I have a pair of 3s and a pair of 2s. So that's going to be 6 times a half, which is 3. So that's 2 times 3, which is 6 times a half, which is 3. So negative and the negative. So negative, I'm going over here, negative 3 on the outside, and then radical 3 left over, and then an I. This is I. So I, and then radical 3 left over. So negative 3I radical 3 would be the simplified. So these are just like the other radicals we did, except now you're going to have an I in your answer because the negative. Basically, you see a negative under the radical, you put an I. It's pretty simple. All right, example 2. So here we have, this is going to be 10I minus 3I, and that's 7I. Just operations now adding. So this is radical 3. We can't do anything with that, but there's an I, so it's I radical 3. And this is going to be 12 is what? 4 times 3, and that's 2 times 2, pair of 2s. 2 times 4, so it's 8I radical 3 plus 1I radical 3. That's 9I radical 3. 9I radical 3. And then here we got some work to do. I'm going to break it. So what I'm going to do is I'm going to break it down like it's just a regular 28. Just remember there's an I there. And then 2 times 2, pair of 2s. 56 times 2, 28 times. Well, how about 9 times? No. 28 times 2. 14 times 2. 7 times 2. Pair of 2s, pair of 2s. That's a 4I radical 7. 4. Let me erase that. 4I radical 7, and this is going to be 4 times 2, so 8I radical 7, and this is going to be 9 times 7, and then 3 times 3. Pair of 3s, 3 times 2 is 6, minus 6I radical 7. And again, the I, just because of the negative in each one. 8I radical 7 plus 4I radical 7 is 12I radical 7 minus 6I radical 7. That gives us 6I radical 7. 6I radical 7 would be the addition there. Powers of I. Here's an interesting thing, and this is the last thing we're going to do in this lesson here. Powers of I. We already know that I squared is negative 1. We talked about that. So let's fill in what we know. We know I to squared is negative 1. We already did that. We talked about why. I to the first power, well, anything to the first power is just itself. So whenever you see I to the first, it's just I. That's pretty obvious. I to the 0, well, anything to the 0 power is 1. You should have learned that at some point in your math career, and if you didn't, you're learning it now. I to the 0 power is 1. I to the third, okay, I to the third can be represented by I squared times I to the first, because you add exponents when you multiply. So I squared is negative 1. I'm making a substitution. And then I to the first is just I. So that's going to give us negative I. Negative I. I to the fourth is going to be I squared times I squared. And that's negative 1 times negative 1. And that's because I squared is negative 1. We talked about that. So we're referring to things we already know. Negative 1 times negative 1 is just 1. I to the fifth is I squared times I to the third. I squared is negative 1. And I to the third we said was negative I. So what's negative 1 times negative I? That's positive I. Keep going here. I to the sixth will be I squared times I to the fourth. You add exponents. So I squared is negative 1. And I to the fourth we said was 1. Negative 1 times 1 is negative 1. I to the seventh will be I squared times I to the fifth. I squared is negative 1. I to the fifth we said was I. Just referring back to this. Negative 1 times I is negative I. I to the eighth is I squared times I to the sixth. Add exponents, right? Negative 1 times, we said I to the sixth was negative 1. Negative 1 times negative 1 is 1. I to the ninth, I squared times I to the seventh. See if you could finish these without me. I to the seventh is negative I. Negative 1 times negative I is I. I to the 10th, negative 1 times 1, negative 1. And I to the 11th is I squared times I to the 9th, and that's negative 1 times I. And that's going to be negative I. So hopefully you start to see a pattern here as we go through. 1, I, negative 1, and negative I. Here, I to the fourth is 1, and then it goes I, and then negative 1, and then negative I. And then it goes 1, and then I, and then negative 1, and then negative I. It just keeps repeating because you just keep multiplying by I squared, right, times 2 earlier, all right, and it's just a repeating pattern over and over again. It repeats every 4. So the I to the 12th we know is going to be 1, and then I to the 13th is going to be I, and then I to the 14th is going to be negative 1, and then I to the 15th is going to be negative I, and then so on and so forth. They can ask you I to the 386th, all right, and you just have to keep counting. Wait, I have to count all the way up to 386? No, you don't have to do that. Maybe you could come up with a shortcut. Do you see a shortcut? 1I, negative 1, negative I. 1I, negative 1, negative I. 1I, negative 1, negative I. The pattern repeats every 4. So if you could just chop off blocks of 4, the remainder is going to be the new exponent. And that's how we're going to do these powers of I. It'll take a little bit of practice, but it really isn't bad. So, where are we at here? Oh, I'm on the wrong page. So, we'll see how it works out here. Here's some examples here. So, we already did it. Oh, here's multiplying. So, this is 9I times 5I, and this is 45I squared. See that? So you can't just multiply the radicals with negatives in there. You have to get them to I first, and that's 45I squared. I times I is I squared. And then I squared is negative 1. So 45 times negative 1 is negative 45. So A is negative 45. Now here we have powers of I. 3 times I to the third is 3 times, and I to the third is negative I. Just look at the page before. All right? Minus, or times, I'm sorry, times, there's a times here, negative 4 times, this is times, I to the 13th, what did we say I to the 13th was? I to the 13th is I. I to the 13th is I, so we go times I. And this is negative 3I, negative 3I times negative 4I. So that's going to be 12i squared, but then I squared is negative 1. 12 times negative 1 is negative 12. So I get negative 12 there. Now here, when you're adding, you have to simplify them each separately. So I get 4i. I get 4i plus 5i to the 8th. I to the 8th. I to the 8th is 1. All right, so 5 times 1 plus I to the 3rd is negative I, 6 times negative I, and then plus 2 times 1. I to the 4th is 1. So it's 4i plus 5 minus 6i plus 2. Combine like terms, 5 and 2 is 7. 4i minus 6i is negative 2i. You can only combine like terms, and there we go. Now, I to the 98th, you got options. You can either count 1i, negative 1, negative I, 1i, negative 1, negative I, count, all the way up to 98. Or, here is the shortcut. Take the exponent, 98, divide it out by 4, because the pattern repeats every block of 4. Divide by 4, long division. 4, we know long division, right? 4 goes into 9 twice. Subtract. 4 goes into 18 4 times, and we subtract with a remainder of 2. That remainder, write this down, remainder becomes the new exponent. So this is going to be, I to the 98th is I squared. I to the 98th becomes I squared, and now simplify it. We know I squared is negative 1. So you get all the way down to negative 1. So I to the 98th reduces down to I squared after you divide it out, and then it becomes negative 1. I'll see you in class tomorrow.